Hello, everyone. My name is Wang from University of Alberta. Sorry, I cannot go to the conference in person because the visa issues. So sorry about that. Today, my poster presentation is about the size-based separation and analysis of trace elements in operotrophic peatland waters. The dust particle generated from open pit mining activities are considered primary pollutant and dominant source of heavy metals in surrounding operotrophic peatlands, which also known as bog. The reactive mineral phases of this dust have the potential to dissolve and then release essential or potentially toxic elements in bog water just due to its low pH, like pH 4. The mobility, bioavailability, and even toxicity of these elements highly depends on their size distributions and also their chemical forms. Therefore, we report an analytical method to analyze the chemical forms of trace elements in the salt fraction of the bulk surface water, as well as spectral mass water as a function of size using AFO UV ICP-MS and fractogram convolution. The feature 1 shows operotrophic peatland and feature 2 shows the spectral mass, a dominant land species in operotrophic peatland. We collect our samples, surface water samples and spectral mass using ultra-clean sampling method in the Athabasca bituminous sands regions, Alberta, Canada. The spectral mass water will just squeeze from the leaving layer of spectral mass in the swampland, which known as the ultra-clean mental-free facilities at the University of Alberta. A PTFE membrane filter with a 0.45 micron pore size and 30 millimeter diameter were employed to obtain the dissolved fraction of trace elements in those waters. The asymmetric flow-free flow fractionation closed-flow program and channel setup were all shown here. We employed UV visible absorbance for characterizing dissolved organic matter and also inductive coupled plasma mass spectrometry for characterizing trace elements. We use that convolution technology to decompose the overlapping peaks into their peak components, get a high resolution of size distribution of trace elements. Result and discussion. We met some challenges when we developing this method, as shown in the figure 4A and B. The colloids, especially the dissolved organic matter in both moss water and spectral moss water, tend to accumulate on the polyacetone membranes under acidic conditions due to electrostatic interactions between colloids and membrane, decreasing the effective pore size and potentially reducing the close flow rate and separation capacities if the membrane pore size is too small. Therefore, applying the membrane with larger pore size, for example, 1K Dalton for moss water or 5K Dalton for bulk surface water, can help minimize the impact. The copper and yttrium, as shown in the figure 4C, cannot be reliably measured because the contamination issues during the fractionation of sample colloids. Therefore, the system needs to be conditioned using matrix match materials before analysis to remove contamination and minimize the artifacts. Distribution of trace elements in bulk surface water and moss water. We identify 3 different chemical forms in such waters. So first, ionic and a small molecule species reach molecular mass less than 1K Dalton. We find it for both waters, as well as dissolved organic matter associated species reach molecular mass 1.3K Dalton for both water too. The inorganic particles, such as species, are very interesting. We only find it in the spectrum Mars water with a higher concentration and also a border size separation, size distribution. The difference between the distribution of trace elements in these two types of water might be due to the incomplete dissolution of gas particle in Mars waters, because the equilibrium time with gas particle was shorter for Mars water than the box surface waters. Let's draw a conclusion. The dominant forms of trace elements in box surface water were either simple small inorganic complex or dissolved organic matter associated species. Second, a great proportion of inorganic species were found in Mars water, and both a higher concentration and broader size distribution of trace elements. These inorganic particles were just from the dust particles deposited on the spectrum of Mars. This work has demonstrated that AFO UV ICP-MS with that convolution analysis is promising to measure changes and difference in the size distribution of trace elements in the dissolved organic matter rich and acidic or protrophic peatland waters. If you have any question, please contact me by email. My name is Wang. You can also call me Wang. That's my English name. Email yw25@ulberta.ca. Thanks for your attention.